What were the limits of Roman engineering? If you're curious about the impressive engineering feats of the Romans, but also wonder where their capabilities reach their limits, you're in the right place. Let's explore the challenges and limitations that Roman engineers faced. One of the significant limits was the complexity of building around existing ancient structures. In modern Rome, engineers have to work around or under ancient ruins like the Colosseum and the Pantheon, which makes planning and designing new structures much more difficult. Instead of building new, they often focus on improving or covering up the old structures, which can be quite challenging. When it came to aqueducts, Roman engineers had to navigate through a multitude of challenges. For instance, the planning and construction of aqueducts required careful surveying to ensure the water flowed consistently. They used tools like the chorobates and groma to plot the course, but maintaining a constant gradient was crucial. A gradient of not less than 1 in 4,800 was recommended to prevent erosion and water pressure damage. The length and complexity of aqueducts also posed significant challenges. Aqueducts could be over 100 kilometers long, and maintaining them was a constant task. Debris accumulated in the conduits and leaks developed over time, requiring regular inspections and repairs. For example, the Aqua Marcia, which ran for about 91 kilometers underground and 10 kilometers above ground, needed constant maintenance to ensure water supply. Tunnel construction was another area where Roman engineers faced substantial limits. Digging tunnels through hills and mountains was a slow and labor-intensive process. The canot method, which involved digging vertical shafts at regular intervals, helped ensure the tunnels stayed on course, but it was still a time-consuming process. The counter-excavation method, where workers dug from both sides of a mountain, required precise surveying and could take years or even decades to complete. For example, the tunnel built by Emperor Claudius to drain the Fucine Lake took 11 years and involved 30,000 workers. The materials used also had their limitations. While the Romans developed waterproof concrete and used lead pipes, these materials were not immune to issues. Lead pipes could accumulate calcium carbonate deposits, reducing water flow rates, and the concrete linings could be damaged by tree roots and other external factors. In terms of public health and equity, the distribution of water was another limiting factor. Water supply was prioritized for public fountains and baths over private users, and the system was not always equitable. Wealthy citizens often had better access to water, and the allocation of water rights could be contentious. In summary, while Roman engineers achieved remarkable feats, they faced significant limits in terms of working around ancient structures, maintaining long and complex aqueducts, constructing tunnels, dealing with material limitations, and ensuring equitable water distribution. These challenges highlight the complexity and ingenuity required in Roman engineering.